In this video, I'm going to show you how to solve for side lengths of our special triangles. And we have two types of special triangles. We've got 30, 60, 90 triangles and 45, 45, 90 triangles. The first one I'm going to do, actually the first two are 30, 60, 90s. So first we need to remind ourselves what our rules are for this. And we always call the shortest side x. Our hypotenuse is 2x and the other leg is x squared of 3. And that is if this angle right here is 60 degrees, okay? And that means that this angle up here is 30 degrees. So once we remember that, we come over here and the first question we have to ask is, okay, what side do we know? In this case, we know the leg, that is the same as x squared of 3. And there's some different ways to think about this. I like to think of this as, well, that's the same side, so I can set those two things equal to each other. So I'm going to go 7 squared of 15 equals x squared of 3. And we want to solve for x to find the short side down here. So to solve for x, we need to divide by the square root of 3. Divide by the square root of 3. We get x equals, and here we need to know how to simplify this. Okay, when you see a square root on top of a square root like this, we can divide directly in that square root. So really what we're doing, this is 7 times the square root of 15 over 3. And 15 divided by 3 is 5. And so 7 squared root of 5 is x. So we fill that in our diagram, 7 squared root of 5. And now we need to find our other side length, 2x. So 2 times x is just 2 times 7 squared root of 5. And we're just multiplying here. We get 14 squared root of 5. 14 square root of 5. And there we just solved for our two side lengths that we're missing. Let's look at another example. Remember again, here's our triangle. We've got x square root of 3. Excuse me, that's 2x. Sorry about that. Got 2x over here, and then x squared root of 3. All right, we know our 2x. So to solve for x, we would just simply say, well, 2x equals 13. That means x has to be 13 divided by 2. Another way I ask this sometimes to my students, I say, okay, if we know what 2x is, how do we get from 2x to x? Well, we have to divide by 2 to get from 2x to x. So x is 13 over 2. And to find our other side length, we need to multiply by the square root of 3. So 13 over 2 times the square root of 3. Well, we can just think of that as 13 square root of 3 all over 2. So this side's 13 square root of 3 over 2. And that's how we solve our 30, 60, 90s. Let's look at our 45, 45, 90s next. And these ones are nice because these are actually isosceles triangles. Since both of our angle measures are 45 degrees, I'll draw a little diagram over here, but both of our angle measures are 45 degrees, so that means that our two legs are the same. Okay? We see a 45, 45, 90. And this other one over here, our hypotenuse is always x squared of 2. So if you have x squared of 2 and you're trying to find x, it's much easier because you only have to solve one time. You don't have to do it again. So right away, since both of these sides are x, we can call our other leg 7 squared of 2. And now to find x squared of 2, well, how do we get from x to x squared of 2? We multiply by the square root of 2. So 7 squared of 2 times the square root of 2. We know square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2, 7 times 2, and that is 14. That's our hypotenuse on that one. If we have our hypotenuse and we're wanting to solve for a leg, well, remember, our rule over here, of course you maybe would have this in your notes, I would hope. You don't have to solve each time. This is x, other leg is x, and our hypotenuse is x squared of 2. How do we get from x squared of 2 to x? Well, we have to divide by the square root of 2. So 4 squared root of 2 is the same as x squared of 2. Some of you are already looking at this and saying, oh, it's 4, obviously. Okay, to do this algebraically, we just divide by the square root of 2 on both sides. And 4 equals x. 4, and 4. So I hope these are some good examples to help you get started on your homework if you're stuck, or if you're just wondering how we solve for our special triangles.